Generator connection accessories. Surge protection voltage transformer cubicles. Introduction. Surge protection voltage transformer cubicles are single-phase units, one for each phase, each comprising voltage transformers up to a maximum of 4 per phase, a surge capacitor, and a surge arrestor, with or without surge counter. Its enclosure is connected to the isolated phase bus tap-off bus enclosure through a rubber bellow to electrically isolate the cubicle. The conductor is connected to the isolated phase bus tap-off conductor through a flexible laminates. The isolated phase bus tap-off conductor is connected to the cubicle incoming through a seal-off bushing mounted on the cubicle. If the surge protection voltage transformer cubicle bus is specified to the same short-time rating as that of the tee-off conductor of the isolated phase bus, the size could become unwieldy for large turbo alternators. Further, seal-off bushings with an embedded or assembled conductor may become large and expensive. Therefore, some of the specifications suggest incorporating current-limiting resistors inside the cubicle to limit the prospective fault current to practical levels without affecting the accuracy of measurement of the voltage transformers. There have also been instances where fuses have been incorporated in the tap-off bus just ahead of connections to the incoming seal-off bushings of the surge protection voltage transformer cubicle. Fuses, rated for clearing a prospective fault current of 200 kA RMS, are available. Since the possibility of the conductor in the single-phase surge protection voltage transformer cubicle experiencing the rated tap-off short-circuit current is practically remote, a conductor cross-section with a lesser short-time withstand capability may be installed in consultation with the project authorities. This concession would make the interface connection more practical without sacrificing performance. It is preferable to have a single-phase surge protection voltage transformer cubicle for large turbo alternators. 3-phase units may be manufactured and installed for smaller unit ratings. There are 2 specific advantages of installing single-phase units for large machines. It practically eliminates the possibility of a phase-to-phase fault, one of the very important criteria for large generator connections. The tap-off connections from the main isolated phase bus to the surge protection voltage transformer cubicle will become extremely simple and elegant since the phase spacing of the individual cubicles can be made equal to the phase spacing of the isolated phase bus. The connection will be short and straight. In many of the isolated phase bus layouts, there may not be adequate clearance between the bottom of the main bus and the top of the surge protection voltage transformer cubicle to install a bend, a rubber bellow, and a bonding bar. In most of the layouts, the entry of tap-off bus to the surge protection voltage transformer cubicle is from the top. If the situation demands, bus can be terminated from the rear or the bottom of the surge protection voltage transformer cubicle. In the case of 3 single-phase cubicles, it is the practice to have an individual marshalling box per cubicle along with a common marshalling box to bring all the connections of the 3 phases into one location. In a 3-phase surge protection voltage transformer cubicle, secondary wiring from the various components such as voltage transformers, cubicle illumination lamps, and anti-condensation heaters can be brought to a single marshalling box. The cubicle body is earthed to the station grid. Voltage transformers along with the primary protection fuses, if provided, are mounted on a draw-out trolley. It should be possible to draw out the voltage transformer under live conditions. This may be required for the replacement of the fuse or the defective voltage transformer. While withdrawing, the following sequence of operations for the voltage transformer is ensured. Secondary contacts get disconnected. Primary contact gets disconnected. Secondary and the primary contacts get earthed after safe clearance is established. While plugging in the voltage transformer, the sequence of operation is reversed. The trolley should be positively earthed at all times. On withdrawal of the voltage transformer, safety shutters automatically isolate all the high voltage connections. The draw-out trolley is linked to the panel door through a linkage mechanism that automatically performs the sequential operation. Other types of mechanisms have been designed that perform similar safety operations for the replacement of voltage transformers or primary fuse. Surge arresters and surge capacitors are always installed in fixed execution. Generators are connected to the generator transformers with or without a generator circuit breaker in between. In the absence of a generator circuit breaker, one set of surge protection voltage transformer cubicle is installed by taking a tap-off from the main connection between the generator and generator transformer. The unit is synchronized with the grid by closing the circuit breaker connected to the high voltage side of the generator transformer. The synchronizing relay gets the signal from the voltage transformer connected to the generator connections and voltage transformer connected to the grid. If a generator circuit breaker is installed in the generator connections, the unit is synchronized by closing the generator circuit breaker. The synchronizing relay gets the signal from the voltage transformers located inside the surge protection voltage transformer cubicle installed on either side of the generator circuit breaker. Voltage transformers. It is the norm to use dry-type, cast resin voltage transformers in the cubicles. The thermal insulation of Class B should be adequate. A few specifications call for fuses to be incorporated on the high-voltage side of the voltage transformer for protection. For large generators, the rupturing capacity can be so high that fuses for the specified prospective fault current ratings are not in the range of manufacture. Few accept a lower rupturing capacity for operation in conjunction with the current limiting resistors. A majority of the specifications do not recommend fuses for protection on the primary side of the voltage transformers. As mentioned earlier, the fuses are not expected to encounter the rated prospective fault current under practical conditions. The user may explore the possibility of incorporating a fuse of lower rupturing capacity that is readily available. One of the most common causes of failure of the voltage transformer is the inter-turn or interlayer insulation failure on the high voltage winding. Some designs of voltage transformers have a built-in provision for installing a fuse. Voltage transformers are resin encapsulated. The core of the transformer should be positively earthed. It is preferable to install a voltage transformer with fully rated bushing for earth connection. This would require a complementary coil design and will permit power frequency voltage withstand test. The voltage factor of the voltage transformer should be 1.9 continuous. Surge protection scheme. Voltage surges reaching the terminals of the generator could be the result of a direct or indirect lightning strike on line on the high voltage side of the generator transformer, switching or fault clearance operation of high voltage circuit breaker in generator bay of the switchyard, switching or fault clearance operation of generator circuit breaker, arcing ground fault. The basic insulation level of the isolated phase bus is far higher than that of the generator. These surges will have to be contained not only for the safety of the isolated phase bus but more importantly for the generator. It is therefore important not only to limit the peak of the surge wave but also smoothen the slope of the front of wave. Inter-turn and interlayer insulation of the voltage transformers and generator are sensitive to the slope of the voltage surge wave. Peak will stress the major insulation. The surge arrestor will clip the voltage surge wave to the safe limit and the capacitor will reduce the gradient of the front of wave of the voltage surge. Surge capacitor. Surge capacitors are installed to reduce the gradient of the front of wave of the voltage surge. The recommended value of the capacitors is 0.125 microfarads or 0.250 microfarads, depending upon the size of the generators. Surge capacitors also absorb surge energy depending upon the rating of the capacitor. Capacitors with solid insulation are preferred. The surge capacitors shall be rated for a minimum of the line-to-line voltage. It has a significant contribution to the total line-to-ground capacitance for the sizing of the resistor or reactor connected to the secondary of a neutral grounding transformer. Surge arrestor. Surge arrestors are installed to limit the peak of the voltage surge wave, well within the safe withstand capability of the generator. All the surge arrestors are non-linear types, using zinc oxide elements. Since the surge arrestors are installed inside an enclosure of a cubicle, it is preferable to have the composite insulation housing made of fiberglass cylinders that are filament wound and enveloped by silicone rubber petticoats. Fiberglass cylinders have very high hoop stress withstand capability, unlike a porcelain housing. These composite insulation housings have become popular and are replacing the housing not only for indoor applications but also for outdoor ones. Depending upon the surge energy and the capability of the surge arrestor, porcelain housing can shatter, causing collateral damage to the other installed equipment in the surge protection and voltage transformer cubicle. It is very important to select the right parameters for the surge arrestor to ensure insulation coordinations. One of the important parameters is maximum continuous operating voltage, MCOV as per IEEE, or continuous operating voltage, UC as per IEC, is the maximum RMS value of power frequency voltage that can be applied continuously across the terminals. The selection of MCOV or UC of an arrestor will depend not only upon the rated voltage of the system but also upon the system grounding. The generator neutrals are grounded through a high impedance, and therefore the ground fault factor should be taken as 1.732. For a generator with a terminal voltage of 13.2 kV, MCOV or UC shall be greater than 14.52 kV. When a lightning arrestor absorbs the surge energy, it gets converted to heat, and pressure starts building inside the housing. Once the pressure exceeds the threshold value, it is released through the vents and external arc inception may occur. Under these conditions, the arrestor must be replaced. The surge energy absorbing capability is measured by a parameter that is assigned to the arrestor in terms of kilojoules per kilovolt. It is proportional to the discharge current capability of the arrestor. A station-class surge arrestor with a 20 kA discharge current will have a higher value of kilojoules per kilovolt than one rated for a 10 kA discharge current. The higher the energy absorbing capability, the lower will be the probability of the arrestor's failure. Surge counter. A surge arrestor can be fitted with a surge counter. The surge arrestor is mounted on an insulating base and the connection to the earth is made through the counter. The surge counter has a facility to measure the leakage current. This is an indication of the health of the surge arrestor. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.